Imagine standing on the edge of our solar system, gazing out into the vast expanse of space. In the distance, you see a faint glimmer, Alpha Centauri, our nearest stellar neighbor. It seems so close, yet it's so far away. Today we're going to explore why reaching this cosmic neighbor is one of humanity's greatest challenges. Hello, space enthusiasts. Today we're tackling a question that has puzzled scientists, engineers, and dreamers for decades. Why is it so tough to get to Alpha Centauri? We will explore the vast distances of space, examine the technological challenges we face, and investigate innovative ideas that could one day connect Earth with our neighboring stars. Buckle up, because we're in for an interstellar journey. To understand the challenge of reaching Alpha Centauri, we first need to grasp the sheer scale of the universe. Let's start with something familiar, our own solar system. Within this relatively small cosmic neighborhood, we have 8 planets orbiting the Sun, along with numerous moons, asteroids, and comets. Despite their presence, the distances between these celestial bodies are vast, with the closest planet, Venus, being approximately 25 million miles away at its nearest approach. Now let's zoom out to see where Alpha Centauri is in relation to us. Alpha Centauri is about 4.37 light-years away from Earth. That might not sound like much, but let's put it into perspective. A light-year is the distance light travels in 1 year. Light moves at an astounding 299,792,458 meters per second. To reach Alpha Centauri, we'd need to travel at the speed of light for 4.37 years.
6, 5, 4, 3, 2, 1. MDS, we have ignition, we have a liftoff.
Roll program is in on time. Vehicle response is normal.
TVC bus voltage looks good. Tank pressures look good.
Okay, MDS.
Engine program was in on time. Vehicle response was normal also.
Let's consider the second fastest spacecraft, the Voyager 1 probe. Launched in 1977, it travels about 17 kilometers per second. It would take Voyager 1 about 73,000 years at this speed to reach Alpha Centauri. That's longer than all of recorded human history. Parker's solar probe broke Voyager 1's record on September 27, 2023, when it reached a blistering 635,266 kilometers per hour as it swooped close to the Sun's surface, thanks to a bit of gravity assistance from a close flyby of Venus on August 21st of the same year. In terms of conventional spacecraft, which travel at significantly slower speeds, the journey could take tens of thousands of years. By putting our solar system in perspective, we begin to appreciate the extraordinary challenges involved in interstellar travel and the technological advancements needed to overcome them. So why can't we just build a faster spacecraft? Well, it's not that simple. Let's look at our current propulsion technologies. Our most powerful rockets today use chemical propulsion. They work by burning fuel and expelling the hot gases to create thrust. But there's a catch. We call it the tyranny of the rocket equation. The faster we want to go, the more fuel we need. But more fuel means more mass, which in turn requires even more fuel to move. It's a vicious cycle that makes it incredibly difficult to reach the speeds we'd need for interstellar travel. To reach even a fraction of the speed of light would require enormous amounts of energy. For example, to accelerate a 1,000 kilogram spacecraft to just 10% of the speed of light would require about the same amount of energy as the entire United States consumes in a year. Even if we could reach the necessary speeds, we'd face another set of challenges in interstellar space. The space between stars is filled with cosmic radiation, high-energy particles that can damage spacecraft and be lethal to human crews. We'd need to develop advanced shielding technologies to protect against this constant bombardment. Space isn't empty. It's filled with gas and dust, the interstellar medium. At the high speeds required for interstellar travel, even tiny particles could cause significant damage to a spacecraft. Another challenge is communication. Radio waves travel at the speed of light, which means any message sent from Alpha Centauri would take 4.37 years to reach Earth. This makes real-time communication impossible and complicates mission control. Despite these challenges, scientists and engineers are working on innovative solutions. One promising technology is nuclear propulsion. Nuclear propulsion could potentially provide much higher speeds than chemical rockets, potentially reducing travel times to Alpha Centauri to a few centuries rather than tens of thousands of years. Even more exotic is the concept of antimatter propulsion. Antimatter releases enormous amounts of energy when it comes into contact with regular matter. If we could harness this energy, we could potentially reach a significant fraction of the speed of light. One of the most exciting current projects is Breakthrough Starshot. This initiative aims to send a fleet of tiny, lightweight probes to Alpha Centauri, using powerful lasers to accelerate them to 20% of the speed of light. If successful, these probes could reach Alpha Centauri in about 20 years. Now that we understand the challenges, let's take a closer look at our destination. Alpha Centauri isn't just one star. It's a star system consisting of 3 stars: Alpha Centauri A, Alpha Centauri B, and Proxima Centauri. In 2016, astronomers discovered something exciting: a planet orbiting Proxima Centauri. This planet, Proxima B, is roughly Earth-sized and orbits in the habitable zone of its star, where liquid water could potentially exist on its surface. If we could reach Alpha Centauri, it would be a monumental achievement for humanity. We could study a star system up close, potentially explore an exoplanet, and take the first step in becoming an interstellar species. The journey to Alpha Centauri represents one of the greatest challenges humanity has ever faced. The vast distances, technological limitations, and hazards of interstellar space make it an incredibly difficult goal to achieve. But as we've seen, scientists and engineers are working tirelessly to overcome these obstacles. While we may not reach Alpha Centauri in our lifetimes, every advancement we make in pursuit of this goal pushes the boundaries of our knowledge and capabilities. Who knows? The technologies we develop in our quest to reach the stars might just help us solve some of our most pressing problems here on Earth. Thank you for joining me on this cosmic journey. If you enjoyed this video, don't forget to like, subscribe, and share. Until next time, keep looking up and ask, why? On YouTube.